Okay, mean, median, mode. Now, before going to variance, before entering that calculation, let me, I think we may have done this once, but let's see, let's find out. One of the fundamental principles of statistics is derived out of a old razors. It's an it's an old razor. A razor in Kannada is called Gademat. Okay, and in Hindi, Kahavat. In in English, it's called a razor or a quote or a philosophy. So this old razor is called Occam's razor, derived out of the name of a person called Wilhelm of Ockham, a place in England or some place. Okay, this comes from I think 16th century or something. 16th century. This philosopher used to be there, and he had a old adage or old. He had a common philosophy, and this Occam's razor used to be used. We used to use Occam's razor's principle to resolve conflicts. Have we talked about this? Have we spoken about this? No, Vikash?
No, no, I don't
No,
think
No,
so.
sir.
no, okay. This used to be used to resolve conflicts. What are we doing? We are resolving conflicts, correct? Correct, Manjunath? Resolving conflicts.
Yeah, yes.
Conflicts are usually, some conflicts means conflicts of misunderstanding. And misunderstanding means no proper understanding, correct? And understanding comes out of data. So, this principle of Occam's razor used to ingest the data related to events and further resolve the misunderstanding. You can think of Occam, Willem of Occam to be in a position of something, somebody like a panchayat leader or a head of a village, right? Or in the real sense, he probably was a head of a church who used to get all these issues, and those issues he would resolve. What was the principle? The principle stood for something like this. The statement of the principle is what I'm going to tell you now. When faced with competing theories, choose the theory with least assumptions. When faced with competing theories, choose the theory with least assumptions. This is what he had proposed, and he used to follow this, and people started following this everywhere. Now I want you to take an example and understand this. Suppose I'll draw I'm just drawing Willem of Ockham here, who is now faced with two people. Two people are here, and there is an issue where both of them are giving, there is some robbery, and two people are suspect. Some robbery, and two people are the suspects. And now he has to listen to both. Okay, so they both were around that area, that house or wherever it is, and both have been caught. And now this person is saying, no, I didn't do the robbery, and this person is also saying, I didn't do the robbery, and they are giving their own explanations. Okay, so it is but natural that you will have to listen to their explanation. Explanation of A. And you have explanation so both are saying why were they present at that particular time. So one person says, explanation A says, I have a house next door and I was passing by, heard the sound and came. B also gives similar explanation. I was passing by, I heard a sound and I came. Both have told the same explanation. But this was having a house next door was verified. But now the question is, why were you there? Just the sound? Where did you listen to the sound? How far were you? Why were you passing there? See, these are all the questions that he'll have to answer, correct? Vikash and
Yes, sir. Right.
these questions he'll have to. So he will make up some answers for this. How far I was, some 300 meters away. Why were you there? Then he'll make up another. I had, went to buy something. So he will build on more assumptions. This guy less assumptions. Now for Occam to accept him as the person saying the truth, he will have to do with less assumptions to get to the truth. But here, to say B is right, he will have to assume that somebody from 300 meters can really listen to a sound. Means what? Hidden assumptions are someone from 300 meters away can hear the sound. Which means what? Hidden assumptions. Which means B's hearing capacity is superiorly high, that he's an outlier. Okay, assumption one. Next, passing there, went to buy something. Second assumption here, that he needed something, but had time to enter the house. All of this, right? So many assumptions. To say B is right, you have to inherently assume all this. But what does Occam's razor say? When faced with competing theories, choose the one with least assumption. Choose the answer given where to agree that this person is saying the truth. He will have to assume less. So don't you think here already you can sense using that principle that A is more likely not to be the robber and B is more likely to be the robber? Can you not see this?
Yes.
Yes, sir.
So in every case, in every guesses that you make in statistics, in statistics, I told you earlier that stats is all about determining the best guess, correct? So your stats calculations or the numbers which gives you the sense about distributions. These senses or the sense that you're drawing is only to enumerate the assumptions that we may make when calculating the risk. To enumerate this, once it is enumerated, using that risk. So to get all these enumerations, these different computations, you have measure of central tendency. First thing what you learned today. Second, now what you're going to learn is variance and standard deviation. So let's just take a simple distribution. Here, I think this is a better example, ones which I have already listed over here. What is that? 1, 4, 5, 4, 8. Okay, let's get back to this. Take another distribution. Example 1, 4, 5, 4, 8. We don't care. This 8 could be number of dogs in a neighborhood. One person has 1 dog, 4 dogs, 5 dogs, 4 dogs, 8 dogs. Doesn't matter. Or number of cats, or number of cars, or whatever it is you want to associate with these numbers, it doesn't matter. You can find the mean of this. You can find the median of this. But when you find the mean of this, go ahead and find the mean of this. 5, 5, 10, 14, 14. 822, 22 by 5.
4.
Okay. What does it signify? On an average, this much value is there for each, correct? Even if I want to guess the new, if somebody really forces me to guess the new value here, I would probably guess this much. Because on an average, this much is there. This gives you a sense of its central measure. Then when you take a median of it, you sort it 1, 4, 4, 5, 8, then you get 4. So when you see 4, median is 4 and mean is 4.4, you have more confidence in just saying roughly about 4 and 5, you may get a number here based on what so far we have got. But this is just about the central value. We still have another question. How spread out is the data? This is another question that we need to ask. Fine, the number, this gives you a number of the central value, but it still doesn't give me from this central value how each number is spread out. It is not giving me that. Nothing, we have not computed a quantity which gives us a feeling for how this spread is happening. So for that, we see what we do. We will follow a set of steps and you see what we are doing. First, we find the mean value. How much? 4.4. This is your, okay. Then what we do mu minus x. X is this whole distribution. Mu minus x means what is 1 minus 4.4 minus 1? Means from the mean, how far is this individual number? How much?
3.4.
3.4. Then
0.4.
0.6, huh?
Point,
Mean
0.4.
4. 4 minus 4.4
Oh, 0.4.
minus 0.4. Correct?
Yes.
Now,
We're taking mu minus x, no? So it will be plus 0.4.
okay. Correct. Correct. 4 minus. Correct.
Now
Now,
minus will come.
now
1.4 minus 1.4
minus 1.4. Next.
plus 0.4.
Okay. Now minus 3.6.
Ah,
Okay. So now, what is this distribution telling us? The distance from the center, this is what it tells us. In fact, I should have done this little on the side. This is better. I bring this here. So this is what it means, the difference. Can I write this? 3.4, 0.4 minus 1.4, 0.4 minus 3.6. Okay, basically the question is simply after finding a number, what is that number supposed to tell us about a distribution? That is what we are discovering here. So you see 14548, 3.4, 0.4 minus 1, I am getting this. This is the one which has gone here. Now I can simply take the average of this. But what happens when I take an average of this? This gets minus, right? This gets nullified, the distance. It gets nullified, so we'll get a low value. So instead of that, we do mu minus x the whole square, so that you can remove the negative or positive signs. We could have just taken the absolute, but by squaring it, we accomplish something else. Just now square and tell me.
11.56.
How much is that? 11?
0.56.
Okay.
Then you have 0.16. So the next one is actually zero point 0.6. It is minus zero point 0.6. The number itself. Mu minus x is minus 0.6. So it would be 0.36.
Okay.
Then again same 0.16. 96.
This was there, no? This was there, right? This is a little higher, correct? The difference? But after squaring it, you can clearly see the difference from the mean. You can clearly see it now. That's what the squaring does. So now you take the average of it. Tell me what is the average of it.
Be roughly around 5.2.
How? Because we added all this divided by 5, correct?
Correct, yes. 5.04, sir, exact value.
Okay. So you have 11.56 plus 0.16 plus 0.36 plus 0.16 plus 11.96 is equal to how much it came up to? Just do 5 into 5.04.
It's 25.2, sir.
This divided by 5 became 5.04. Okay, this one, this 5.04 is the variance and always denoted by sigma squared. Variance is always denoted by sigma squared. Finding the variance is okay because you don't have to calculate like this. If you simply code in Python just a var of some list, you will get it. But what does it mean for this to be like this? You can go and check another value now. Let's take a very big number now, okay? Big numbers let's take. Take 100, take 105, take. I want you to do this calculation. Remove the calculator, Manjunath, and you tell me this now. Take 102, take 104, take 99. Now tell me, what is the mean value of this? Mean value 100, 100, 100.
ಕೊಡ್ತಾ
100
ಇದೀನಿ
or
ಸರ್.
400, 400 and
102.
110, I guess.
102, sir.
510 divided by 5, no?
Yeah, correct.
510 sir. Sum.
Divided by
Average
510.
1.
Now what to do next? You have the mean value. What to do next?
Median.
No,
minus x.
you're not fully immersed. No median. We don't need median here. Mean is there. And then mu minus x. Now,
Okay.
give me this. What is this? 102 minus?
Is 102 minus 102.
Then,
X square sir.
ಮಾಡಿ ಅದನ್ನು ಮಾಡಂಗಿದ್ರೆ ಮಾಡಿ. Fine. You square and tell me. So this will be
4.
4. Okay. Next.
ಇದರಲ್ಲಿ ಎಷ್ಟು 150 minus 3.
Square and tell.
Yes, minus 9 ಅಲ್ವಾ ಸರ್?
Minus 3 into minus 3 is 9.
Plus,
Minus
yeah, got it.
99
Zero.
and 102 minus 3. Again 9. Now, average of this 18 plus 8 is 26 by 5. How much? 26 by 5? 5.2.
Yes, sir. Right.
5.04, 5.2. See, distributions number, see, small number, variance giving you a feel. Big numbers, variance giving you a feel. Now let's take another one. This is how it is. We have to calculate this to get a feel for it. 17, 2, 9, 44 and 6. Now, quickly, Manjunath will tell for everything now. Mean value, Manjunath. With calculator. Fatafat, click, 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 calculate ಮಾಡು.
944 ಸರ್, ಟೋಟಲ್ ಸಮ್ ಬಂದು 78.
Divide by?
Average 15.6.
Now, just tell me mu minus x. Then later we'll square it.
Mu is 15 minus 2.6.
Minus 2.6, correct? Are you sure? Did you do it with calculator?
No, it calculated through my mind.
No, do open the calculator from your mobile.
Mu is 15.6 minus 17. 1.4 minus 1.4.
Next.
15.6 into minus 2. 13.2. 30.6.
Next.
15.6 minus 6.6.
Next.
So 44 ಅಲ್ಲ?
44.
Minus 21.8.
Next.
9.65. 9.6.
Square of it.
One point four. 1.96. 13.6. 184.96.
6.6.
43.56.
43.56 is it? Okay.
21.8. 475.24. 475.24.
हो गया.
Okay, okay.
9.6.
9.6. 9.6. 92.16.
Okay, add all this. Because already you're getting a feel for this variance number. See the
Yes, sir. Yeah.
variance here.
So sum is 797.18 and count is 5, total count, and average is 159.436.
150.
9.436.
So your variance is equal to 159.43. Simple numbers, not even as big as this, but because of the change in the distribution, you see this
Hmm.
number became big. Correct?
Hmm.
Now suppose I ask everybody 1,000 people data I have of how many heads you have. So 1,000 people. One, 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 one,
And
one.
1.
Then you do
Is equal to
mu minus
1.
x.
1 sir ಎಲ್ಲ.
ಎಲ್ಲ 1 mu minus x.
1 minus 1 0.
ಎಲ್ಲ 0.
ಎಲ್ಲ 0. Square root 0.
Square is 0. Square root ಆಮೇಲೆ ಬರುತ್ತೆ.
Square 0, yeah.
So variance is
0.
so correct ತಾನೆ ಹಂಗಂದ್ರೆ variance ಅಂದ್ರೆ ಏನು? How much is there a variation? Correct?
Oh,
Is there
okay.
any variation here in the
No
distribution?
variation.
So it is correct, no, then the computation.
Yes. Yes, yes, yes.
Correct? So we have just established that the meaning of the word variance and the steps followed to compute it has some rationale behind it. That is what we have established so far. Simply understanding the steps will not make us good decision makers, because next time you should be able to see the variance itself and come to know that less the variance, less is this number, less variance is there in the distribution. So less variance means what? Less variance means
These are
high.
more closer.
Yeah, right. In terms of words, less variance means high. What ability?
Predictabilities.
Correct. High predictability, less variance. So if you want to simply calculate how the distribution is, find the variance. But without calculating the mean, we can't find the variance. That's why we calculated the mean first. Correct? Manjunath? Making sense?
ಹೌದು ಸರ್ ಕರೆಕ್ಟ್. ಯಾ ಅರ್ಥ ಆಗ್ತದೆ ಸರ್.
So, ನೀವು Manjunath, you can sort of try to record lectures for your own in Kannada itself. Okay, and then you can share notes with me that ನನ್ನ ಹತ್ರ ನೀವು ಕೇಳ್ಬೋದು ನಾನು ಅರ್ಥ ಮಾಡ್ಕೊಂಡ್ರೆ ಕರೆಕ್ಟ್ ಆಗಿದೆಯಾ ಅಂತ. You should give me a presentation next.
ಓಕೆ
Okay, both you and Vikash we should give me a presentation like this, the class like this. Where you take examples, where you explain to me what mean median mode is, what Occam's razor is, then what variance is, what standard deviation is. ಎಲ್ಲ ನೀವು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಬೇಕು ನನಗೆ in whichever language you choose to, English or Kannada. Hmm?
ಓಕೆ
Basically, it doesn't matter whether in which language you're learning. This mental language has no language. Okay, it's a feeling. Number is a feeling. It doesn't matter which language. So I want you to absorb it in your mind. Now, this whole thing is anyway recorded, but do you want me to do something else with this? Maybe I'm not able to. Why am I not able to? You do this. I'm sharing the video with you. You make a small picture of this. See, this is interesting stuff, correct? For different distribution, different variances are there, no? So this is interesting stuff. So you understand that. Next, you have your sigma squared. Let me come back here. 14548. 14548. How much was the mean value of it? 4.4, correct? Your sigma squared was 5.04. Now sigma is equal to root of 5.04, which is, calculate and tell me quickly. Nobody is calculating me the root of it.
ಮಾಡ್ತೀನಿ ಸರ್ ಮಾಡ್ತೀನಿ.
Vikas, what
ನಾನು
happened?
ಬರ್ಕೊಂತ
Yes, sir.
ಇದ್ದೆ. ರಿಟರ್ನಿಂಗ್ ದ ನೋಟ್.
Okay.
Yeah, so it is roughly around 2.2, sir. The square root of this 2.25.
2.4.
2.24. ಯಾ
Now this one is called variance. This one is called
ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಡಿವಿಯೇಷನ್. ಓಕೆ
how much was this mean? Let's go and check this. 102, 5.2. 102, 5.2. This one is
2.280.
2.28. Okay. It you may feel like, okay, so much of writing, so much of, but to get a feel for it, this is nothing. You should be doing this for 1 week. This is how all the big university students, no, big colleges and big, how they do. This is how they do. This is how they teach. Let's just get there. Tell me what was the mu for it. Anyone remembers? 178, is it? Oh, 15.6. No. Yeah.
15.6.
And the sigma squared we calculated was 159.4.
159.43.
159.43. Give me the standard deviation, please.
So 12.62.
12.62. Okay, here you have is equal to 1, sigma squared is equal to 0, standard deviation is
0,
also equal to 0.
0.
Okay, this picture I think should be something which we take a snapshot and share with you. I want you guys to write a explanation explaining things that are happening here. This context I need from you guys. Share. Can you give me the context for this?
Yeah, sure.
Now the interesting part starts. Okay, this is only cutting the onions and cutting the chili, getting the masala done. Now I'm going to put the masala in. The dish is not ready. Only so far we have just accumulated the masalas. You see, these are all the masalas. Now is the main stuff, because what you have, the standard deviation, there is a hidden secret meaning. The standard deviation means what kind of deviation? Deviation is standard. Standard deviation of the distribution, correct? So different distributions. For different distributions, you can see, okay. For different distributions, you can see that
Yes, sir.
there are different means, there are different variances, there are different standard deviations. This standard deviation is, acha, okay, standard deviation is the currency of change in the distribution. This currency of change. Currency is what? Currency means value exchange, correct? In India, there is rupees. In US, it's dollars. So what are these? Currency means what? A, a standard way of depicting value exchange. That's what the currency means. In statistics, that value is around the change. Now you go back and you check. 14548 is only single digit number. Variance 2.2. Standard deviation around 2.24. 100, 105, 102, 104, 99, all triple digit numbers, almost leaving a barring this 99 being very small, but still almost a triple digit number. Standard deviation 2.28. Not much difference between these two. You see this? Not much difference between this and this. But when it comes to a double digit and a combination of a double and a single digit number here, the standard deviation became 12.62. Correct? So what was it talking about then? It was not, it was never about single digit, double digit. It was always trying to map the change from one number to the other number. It was always about the difference between the numbers. This is telling you these computations. 4.4 gave you the average. It has nothing, it is not even telling you about the difference. It only talked about the central. But variance and standard deviation talks about the difference between the numbers. See, don't you think it's just a magical number which talks about how spread out the data is now? The variance and standard deviation. Variance tells you how spread out the data is. Variance and standard deviation talks about, it says, on an average, this much deviation will be found between deviation between dash and dash. Fill up the blanks. Will be found between what and what? Go and check. Between what and what?
Value itself and the means.
Correct. Manjunath?
So standard deviation ಒಂದೊಂದ್ಸಲ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿ ಸರ್ ನಮ್ಮ ಕನ್ನಡದಲ್ಲಿ ಅಂತ.
ಅಲ್ಲ, ವೇರಿಯಸ್ ಅಂದ್ರೆ ಎಷ್ಟು ಸ್ಪ್ರೆಡ್ ಇದೆ ಡೇಟಾನಲ್ಲಿ
ಅದು
ಅಂತ.
ಗೊತ್ತಾಯ್ತು ಸರ್, ಎಷ್ಟು ಸ್ಪ್ರೆಡ್ ಆಗಿದೆ ಅನ್ನೋದು ಗೊತ್ತಾಯ್ತು. ಅದು
ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಡಿವಿಯೇಷನ್ ಎಷ್ಟೇ ಸ್ಪ್ರೆಡ್ ಇದ್ರೂ ಆ ನಂಬರ್ಗೂ ಮತ್ತೆ ಆ ಮೀನ್ಗೂ, ಈ ಒಂದು ನಂಬರ್ಗೂ ಮತ್ತೆ ಅದ್ರ ಮೀನ್ಗೂ
ಹಾ
ಇದೇನ್ ಡಿಫರೆನ್ಸ್ ಇದೆಯಲ್ಲ,
ಹಾ
ಇಷ್ಟು ಡೆಫಿನೆಟ್ಲಿ ಇರುತ್ತೆ ಅಂತ.
ಏನಿರುತ್ತೆ ಅಂತ ಸರ್?
ಡಿಸ್ಟೆನ್ಸ್, ಡಿಫರೆನ್ಸ್,
ಡಿಸ್ಟೆನ್ಸ್,
ವ್ಯಾಲ್ಯೂ ಡಿಫರೆನ್ಸ್. ಒಂದು ವ್ಯಾಲ್ಯೂ
ಹಾ
4.4 ಒಂದು ವ್ಯಾಲ್ಯೂ ಅಲ್ಲ,
ಹಾ
ಒಂದೊಂದು ನಂಬರ್ಗೂ ಅದ್ರ ಮೀನ್ ಜೊತೆ ಇಷ್ಟು ಡಿಫರೆನ್ಸ್ ಅಂತೂ ನೀವು ನೋಡೇ ನೋಡ್ತೀರಾ ಅಂತ.
ಓಕೆ 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 ಓಕೆ, ಅರ್ಥ ಆಯ್ತು.
ಸೊ ದಟ್ಸ್
ಅರ್ಥ
ವೈ
ಆಯ್ತು.
your variance, how it is now, you go and see this one. Variance is simply the average of the squared differences from the mean. It's the average of the squared difference from the mean. That's what it is. That's what we did. See, the average, ಇಲ್ಲಿ ನೋಡಿ, this is the average of the squared difference from the mean.
ಓಕೆ,
Correct? ಉಲ್ಟಾ ಹೋಗಿ ನೋಡಿ.
ಕರೆಕ್ಟ್ ಕರೆಕ್ಟ್ ಕರೆಕ್ಟ್.
Average of the squared difference from the mean. So definition is just definition, comes out of the whole process that we follow. There is no, in statistics it's like this. You
Okay.
have to follow the path and ascertain whether the meaning of this number is actually making sense. Now I will show you another way of looking at this. Copy, come here. You have the standard deviation 2.24, fine. What was its actual difference? Let's take the absolute of it. Where is this?
2.4.
Here, I have this value here. Take the absolute value. 3.4, 0.4, 1.6, 0.4, 3.6. Now, can you express this Can you express this in terms of the standard deviation? ಒಂದಿಂದ 4.4ಗೆ ಎಷ್ಟು ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಡಿವಿಯೇಷನ್ ದೂರ ಇದೆ? How far,
Distance will be the 2.24.
how many standard deviations is this number 1 from its mean? Okay, you tell me this. How many fours are there in 8? So you'll do 8 by 4. So how many fours are
2.
there in 8? 2.
2.
How many fives are there in 15? So I'll do
1.
15 by 5.
3.
3. There are 3 fives in 15. There are 2 fours in 8. I am asking how many standard deviations are there in the distance between 1 and 4.4. But what is 1 and 4.4? 3.4, right? Correct? Distance between 1 and 4.4 is how much?
3.4, sir, correct.
3.4 divided by I want how many?
2.24.
You tell me now what is the value of this?
1.51.
1 point. Are you sure?
1.527 one round up ಮಾಡಿದ್ರೆ 2 ಆಗುತ್ತೆ 1.517.
Vikash, you okay? Correct?
Yes, sir, 1.52, correct.
1.52 sigmas. Can I not write this?
Yeah, you can write, sir.
So like this, I want to express all deviations in terms of standard deviation. Think over it. Think what I have done.
Yeah, sir, I started feeling that I just started comparing with this share market. Why the gamma effect? Why the people will talk about theta effect? So just started feeling because based on the numbers only they will started feeling what is the share market is taking over. If theta is there, I is numbers are there, what's happening to the market? If VIX is increasing, what is going to happening? So just started feeling why the people will stock some numbers. Based on the numbers, they will decide the direction of the market.
Right. But there are more actually that theta and gamma and all are due different kinds of time series calculations that again are based on these only. Okay. If you understand this now correctly, then you can understand that cartoon book very well. So your assignment after 27th, when I'm gonna take a break, okay, you guys, one person will sort of make a very good notes, and I'll give some other added material to Vikash. But for Manjunath, you have to go deeper and start thinking about these things. Okay,
Mm.
because in industry, you can not only say I'm going to be ML engineer only. You have to be open for all positions, data science, a decision scientist, ML engineer. People give different tags, okay? But everybody has to do everything. Finally, what? Prediction. Correct. Prediction, making sure that the data is curated properly and all that things that come up. First, you have to understand why we can't lose the data, why we can't manipulate the data. Okay. So that's and one more interesting thing, suddenly, sometimes, it occurs suddenly. We have to adhere to it. Suppose I scale this data, now assignment for you. Suppose I scale this data by 10.
Mm.
What is the meaning of scaling this data by 10?
Means minus 10.
No.
mu minus x.
Suppose we scale a distribution by x. For example, here scale by 10. So what is the new number now?
Mu
100
is
by
equal to
10. No, 100 by 10. 10.
10.
100 by 105 by 10. That is
Uh,
10.5, 10.2,
10.4,
10.4,
9.
9.9. Now I want you to calculate this, fill this up.
ಹತ್ತು ಇಪ್ಪತ್ತು ನಲವತ್ತು
You will scale this also by, you only find out, okay? I'm going to just give this as an assignment for you. You only find out what happens.
So total is 51.
Divide by 5.
Divided by 5 is 10.2.
Okay, that was so obvious. Then you do all the other,
Yeah.
the difference and all that. You can go ahead and check and see what happens. Ideally, by scaling, because I said what? I said it is the difference between these numbers that matters, correct?
Yeah.
Right? So how much is the zero point 0.5 is the difference between this and this was 5. This was between this and this 0.5, 0.3. So how does this change? By scaling by how does it affect so much? Is what I'm asking you. Okay, you go and calculate it and you send me that in the group after calculation. Correct?
Okay.
So Vikash, following?
Yes. Yeah.
Now that we are able to express each difference in terms of standard deviation, next time when we want to remove an outlier, like we had that example here, I was giving you an example. Where was that? Oh, I was just, yeah, I think I remember that vector. It was 4, 5, 11, then it was 6, right? The difference 6, 17, then 23, and the difference 39. Remember this? That I had clubbed this together and I said this is an outlier.
Yes.
In the last video. Remember this? There was a difference. Now, instead of saying this is an outlier, this is an outlier, that and this, we can simply say remove everything whose which is 1.2 sigmas away from the mean. 1.2 sigma away from the mean. Remove those values. Okay, if you don't follow what it means, what if I say the same thing here? Remove everything which is 1.2 sigmas away from the mean. So you tell me now, 0.4 divided by 2.24, how much is it? Tell me for all.
0.18.
0.18, okay.
And 0.71.
2 point,
No, no, 0.71.
0.71, okay.
Then
Again
again
0.18,
0.18.
okay.
And then 1.61.
Now if I remove everything, remove greater than 1.2 sigma, what am I left with? Manjunath, what will I be left with here? If I remove everything above 1 point, tell me, which number will I be left with? I'll remove this and I'll remove this. No, this is 1.61 sigma. This
ಬಟ್
is
ನನಗೆ ಅರ್ಥ ಆಗ್ಲಿಲ್ಲ
0.
ಅಂತಂದ್ರೆ ಸರ್ ಏನಕ್ಕೆ ರಿಮೂವ್ ಮಾಡ್ತಾ ಇದೀರ ಅನ್ನೋದು ಅರ್ಥ ಆಗ್ಲಿಲ್ಲ. ಏನಕ್ಕೆ ರಿಮೂವ್ ಮಾಡಬೇಕು ಅನ್ನೋದು.
Very good question. Okay, this is outlier. If I have 4, 5, 4, I can
Okay.
predict better. But these are the ones which are bringing uncertainty.
Mm-hmm. So that's why you are removing
Yeah,
uncertainty.
yes. In my
Okay.
data points, I don't want to consider this in my distribution when I build a machine learning model. I will not send this so much variation into my machine learning model.
Okay, you are not inputting all the data. So you are inputting the required exact required data.
Not required. Uniform, at least some uniformity should be there.
Uniformity. Okay.
Yeah.
Okay.
And I'm not saying every time I will do 1.2. I can even choose 1.4.
Okay.
Okay. It is a data scientist decision. What
Okay.
is the sigma that has to be removed above? Usually in one sigma we keep it around one
Okay.
sigma. Okay. Now this sigma thing that comes up, right? This sigma and mean and sigma. This mean and sigma. So after removing what is remaining now? 4, 5, 4, correct?
Yes.
Like this, you can do the same thing for this also, removing sigma, correct? So if this is a list, if this whole thing is a list, easily we can find the mean of L, correct? Then we can find mean minus for each in L,
List value.
correct? Then we can square it and average it, or you can directly find the standard deviation of L. Then we can remove by taking the difference between this mean minus for each value is there, right? Mean of L and for each in L. See, correct?
Yes.
Mean of L minus for each in L divided by standard
But one thing,
deviation
sir,
of
ಆ
L.
ಸ್ಕೇಲಬಲ್ ವ್ಯಾಲ್ಯೂ ಎಲ್ಲಿಂದ ತಗೊಂಡ್ರಿ ನೀವು?
Which scalable value?
ನೀವು ಹೇಳ್ತೀರಾ ಸ್ಕೇಲಬಲ್ 10, ಸ್ಕೇಲಬಲ್ 4 ಅಂತ ತಗೊಂತಾ ಇದೀರಲ್ಲ. Where do
This
you are
is
picking the scalable value?
this scale by 10, is it?
ಹಾ.
This is something which I randomly took.
Okay. Okay. Assumption.
Yeah, it is an assumption.
Okay.
Suppose you are trying to suppose you are doing a scalable. Now question, how did I assume the
Scalable
scaling
value.
factor? Okay. Now this answer to this depends on the
Data.
analysis problem.
Okay.
Okay. I'll give an example. I want to map the salary and age. Now salary will range from 0 to 1 crore package. Age will range from 0 to 100 years. So I will say 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, now here I have to scale in a different way, no? Here also I will scale 10 lakhs per annum, 20 lakhs per annum, 30 lakhs per annum,
Okay.
40 lakhs per annum, 50 lakhs per annum, right? If I don't want, I
Yes.
would scale it in, if my maximum range itself was 50 LPA, then I would say start with 5, 10, 15,
15.
scaling.
Yes. Yes.
Sometimes we normalize both of this. If it is too much, now actually, in fact, this will be too much because this will be 5 lakh means 50000 actual number. 5K, L, 10K, the number system won't understand. This is the actual value. This is your actual value. This is your actual value here, right? See this number and see this number. If you really plot
Hmm.
this, how will this graph look like? If I want to scale it, the graph will look like this. Correct? ಇಷ್ಟೇ because you're 0 to 100, if from here to here, if it is 5 lakhs difference, then how much will be 1 to 100 difference?
Very narrow.
So now I have to scale this to give to
Hmm.
see a graph also. I need to scale this, otherwise I can't even
Yes.
see the graph. Okay, will teach you, we'll show you all this in
Okay, sir.
practical.
Okay. Okay.
But you're getting the Vikas, you're getting the idea, right?
Yes, sir. Yeah.
Right. So that is fine. So here I'm trying a mean L for each in L SD. If you do this, I think you can write a nice, see if you can write a lambda expression for this. I think it's there. Easily it can be written. If not, I'll send you that. Okay. A lambda expression will result in a another list where you have only something like 1.1, 1.3, 1.7, something like that will be there. All this is that many sigmas away from the mean. This one will be a high sigma away from the mean. Like that you will get sigmas away from mean. Depending on what you want to retain, you can retain that. Okay. So that's what we have done here. I think I have done a very good explanation of this in one of the examples. I can share that with you, that whole IPYNB, so you can follow it and check. So basically, you understood why we are doing the standard deviation, right? What is the meaning of a standard deviation, correct? Variance, how spread out the data is. Standard deviation, sigma is just the square root of the variance, but it is usually used in a way to identify the outliers. Data points that lie more than one standard deviation from the mean can be considered unusual. Not always, but yeah, sometimes some slides I have to take it with a pinch of salt. Not always. You can not just one standard. 1.2, 1.3 can be expected. You can talk about how extreme a data point is by talking about how many sigmas away it is from the mean. So this is a new language you're learning for statistics. You don't say, hey, that number is too big. You need an expression, right? You need a way. That new language and the new parlance that you're learning to express the change in the distribution is your standard deviation. So you talk in terms of how many standard deviations. So when you start talking in terms of how many standard deviations something is from the mean, then you start getting this kind of pictures. Now this is called a probability density function. Let's take this. Let's go here. The outcome, as I told you, the masala is still only that's not, I'm not going to teach too much. It will be too much otherwise. I'm just going to show you this. See sigmas, I wanted to show you this sigma here. Where the sigma is. You see this sigmas? Manjunath, you seeing this?
ಸರ್ ಅರ್ಥ ಆಗ್ತಾ ಇದೆ ಬಟ್ ತುಂಬಾ ಕಷ್ಟಪಡ್ತಾ ಇದೀನಿ. ನಾನು ಇನ್ನೊಂದ್ಸಲ ವಿಡಿಯೋ ನೋಡ್ಕೊಂತೀನಿ ಸರ್.
ಓಕೆ ಫೈನ್. ಈಗ ಬೇಸಿಕಲಿ ಏನಪ್ಪ ಮಾಡಿದ್ರೆ ನಾವು 14548 ಇತ್ತಪ್ಪ, ಅದಕ್ಕೆ ಏನು ಮಾಡಿದ್ರಿ, ಮೀನ್ ಕಂಡು ಹಿಡಿದ್ರಿ 4.4 ಸಿಕ್ತು.
ಹೇಳಿದ್ರಿ ಸರ್.
ಆಮೇಲೆ ಅದ್ರ ಮತ್ತೆ ಇದ್ರದ್ದು ಡಿಫ್ರೆನ್ಸ್ ಇತ್ತು, ಆ ಡಿಫ್ರೆನ್ಸ್
ಹಾ
ಎಲ್ಲ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ ಸಿಗ್ಮಾ ಸ್ಕ್ವೇರ್ಡ್ 5.02 ಬಂತು. ಸಿಗ್ಮಾ ವಾಸ್
ಸ್ಟ್ಯಾಂಡರ್ಡ್
2.24.
ಡಿವಿಯೇಷನ್ ಮಾಡಿದ್ವಿ.
ಹಾಂ,
ಆ
ಇದ್ರದ್ದು
ಸ್ಟ್ಯಾಂಡರ್ಡ್
ಕರೆಕ್ಟ್.
ಡಿವಿಯೇಷನ್ ಮತ್ತೆ ತಗೊಂಡೋಗಿ 2.24 4.4 ಜೊತೆ ಮೈನಸ್ ಮಾಡ್ತಾ ಬಂದ್ವಿ.
ಹೌದು, ಸೊ ಇಟ್ ವಾಸ್ ಲೈಕ್ ಯಾವುದೋ ಒಂದು 1.52 ಸಿಗ್ಮಾಸ್ ಆಯಿತು, ಇದರಿಂದ ಏನೋ
ಹಾ
0.18 ಸಿಗ್ಮಾ ಆಯಿತು.
ಆಯ್ತು.
ಎಷ್ಟು
ಓಕೆ ಸರ್.
ಡಿವಿಯೇಷನ್ಸ್ ಇದೆಯಲ್ಲ
ಹ್ಮ್
ಇಲ್ಲಿಂದ ಏನು ಬರ್ತದೆ ಇದು ನಿಮ್ಗೆ ಈಗ ಇಷ್ಟು ಬೇಗ ಅರ್ಥ ಆಗಲ್ಲ. ಓಕೆ, ಐ ಜಸ್ಟ್ ವಾಂಟೆಡ್ ಟು ಶೋ ಯು ದಿಸ್, ಬಟ್ ಐ ನೋ ಹೌ ಟು ಮೇಕ್ ಯು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದಿಸ್, ಆ್ಯಂಡ್ ಬೈ ದ್ಯಾಟ್ ಐ ವಿಲ್ ನೌ ಶೋ ಯು this word. Now you will understand. You must have heard of this word somewhere in your life.
ಸಿಕ್ಸ್ ಸಿಗ್ಮಾ ಹೌದು ಸರ್, ಕೇಳ್ತಾ ಇರ್ತೀವಿ ನಾವು.
What is this
ಸಿಗ್ಮಾ
meaning? Six Sigma certification ಅಂದ್ರೆ ಏನು? ಸಿಕ್ಸ್ತ್ ಸಿಗ್ಮಾ, ಆರನೇ ಸಿಗ್ಮಾ ಎಲ್ಲಿ ಬರ್ತಿದೆ ನೋಡಿ ಇಲ್ಲಿ, ಫೋರ್ತ್ ಸಿಗ್ಮಾ,
ಓಕೆ.
ಫಿಫ್ತ್ ಸಿಗ್ಮಾ, ಸಿಕ್ಸ್ತ್ ಸಿಗ್ಮಾ, ಇನ್ನು 0.1%, ಇದು 0.01%, ದಿಸ್ ಒನ್ ಇಸ್
ನಾಟ್ ನಾಟ್
0.001%.
ನಾಟ್
So what is 0.001%? What is that? 1 by?
1000.
No. 0.1% itself is 1 by 1000.
10,000 ಇರ್ಬೇಕು.
0.1% is 1 by
100
1000.
100
1%
1000.
is 1 by 100.
ಓಕೆ ಓಕೆ.
Now 0.01% is 1 by
ಒಂದು ಸೊನ್ನೆ ಜಾಸ್ತಿ. 1000 ಪ್ಲಸ್
10,000. 0.001 is 1 by
1 lakh.
okay. So your sixth sigma means something that happens once in a lakh. In fact, this should be 0.1, 0.01, 0.001, maybe is after 0.0001, 1 by 1 million.
So does
What?
anybody care about what's happening in ಒಂದ್ ಸತಿಗೆ 1,00,000 ಸತಿಗೆ ಒಂದ್ ಸತಿ ಆಗಂತದ್ದು?
ಹೌದ್ರಿ, people care because see if you are
ಯಾವಾಗ್ಲೂ
manufacturing.
ಒಂದ್ಸತಿ ಆಲಿ ಧೂಮಕೇತು ಬರುತ್ತೆ. ಆ ಆಲಿ ಧೂಮಕೇತು ಎಷ್ಟೋ ಸಾವಿರ ವರ್ಷಗಳಿಗೆ ಒಂದ್ಸತಿ ಬರುತ್ತೆ.
No, wait. Where is this Six Sigma certification used? In industrial process. Correct, no?
ಹೌದು.
Vikash?
Yes, sir, right. In quality
In
testing
quality
and all.
testing, yes. Industrial processes, quality testing. Suppose you are manufacturing a monitor. Okay, you're manufacturing a PC monitor. The industrial process, the process of manufacturing, testing, and compliance and all this should be so strict that at the max you can get one fault out
That's
of.
what you are selling satellites launching.
Correct. One fault out of 1 million. This is acceptable. The Six Sigma is also used for your Chandrayaan also. They said second time Chandrayaan 3, they said, no, this time we have followed the Six Sigma processes, so I don't think it is going to fail. They were very confident that it won't fail because all possibilities of failure was modeled. Okay, I will leave this class with this simple thing. Next time I'll explain what this stands for. If you follow
Sir, you have
through,
recorded this, right?
yes, it is recorded.
Okay, sir.
Okay.
Okay.
If you follow it, it is going to be a little, because you're understanding something. Am I?
Yes, sir, yeah.
Yeah, it's clear. Okay. You should be able to trace the story back. Okay. Sometimes we'll deviate here and there, but then you have to assimilate all the points, and in your mind there should be a free flow story. One thing leading to other. I hope you have followed the process. I hope at least 85 to 90% the flow has been there, save for the some here and there deviations which are required for expanding that horizon, expanding that view and vision, broaden your view of the subject. So that is a given, and yeah, we'll call it a day today. I'll first of all stop recording this. Yeah, it's